Here's an example of a pendulum. If we've got a string that's length 2 meters connected to a mass of 0.1 kilograms, at the moment shown, the string makes an angle theta equals 37 degrees with the vertical, and the bob has a speed of 4 meters per second. What is the tension in the string? The bob's tangential acceleration and the bob's total acceleration. So we're talking about tension. So tension is our big hint that we're needing to do a free body diagram. So we'll start with the easy one. Weight is down, tension is along the string, and that's it. What direction is our velocity going? It's going to go down that curve there, the arc. The weight force is not parallel or perpendicular, so that's going to be the vector that we resolve into components. And we can do that by continuing on down the tension, and then we have mg sine theta, which is the parallel component of the weight. Meanwhile, the perpendicular to the velocity. Anyway, first find the tension force. Centripetal forces are always towards the center. In this case, we can see the tension is pointing towards the center. Well, we also have this mg cosine theta that's pointing away from the center. So we have to do a net force, Newton's second law equation for these two forces right here. The stuff that makes it go will be our tension. The stuff holding it back will be mg cosine theta. And all of that equals mass times centripetal acceleration, where centripetal acceleration is v squared over r. Plugging in our numbers, we get tension equals 1.6 newtons. Nothing crazy difficult there. That's good news, right? Next, we find the tangential acceleration. The only tangential force is mg sine theta. Tangent to the velocity, tangent to the direction we're moving. So stuff that makes it go minus nothing equals mass times acceleration. In this case, tangential acceleration. So masses cancel out on each side, and we're left with g sine theta is the tangential acceleration. That is how fast we are accelerating every second. And that's 6 meters per second squared. To find the total acceleration, we need the tangential acceleration and the centripetal acceleration. Now it's just vector addition. So our centripetal acceleration is v squared over r, which we've got 8 meters per second squared. Tangential and centripetal are components of the acceleration. Remember, the blue is tangential and the red is centripetal. They're at a 90-degree angle. So we can do the tip-to-tail method. We can move this vector up here, and then we can find this resultant vector in pink, the total acceleration. 90 degrees, so we can just use Pythagorean theorem. A squared plus b squared equals c squared. Don't forget to take the square root. Sometimes we get excited that we know what we're doing, and we forget the simple stuff.